Okay, so thank you for the opportunity to present our company and the system. Swidelski, as the name says, is original from Poland, so this was anywhere. Okay, it works. Helmut Swidelski founded the company in 1936, so a long time ago. Very close to Linz. Maybe you know this, between Salzburg and Vienna on the Danube, almost in the mountain area, and starts with railway construction. At the moment, we have around 12,000 employees. And we have different departments, which explained here. We have tunnel construction, we have civil engineering, which is also Atos part of, building construction, railway construction, and of course we have also road construction. Totally turnover, as you can see here on the right side, it's around from last year 3.5 billion euros. Especially in the railway construction, you may know the company already because we are acting in UK. With railway, we are acting almost worldwide. So we have also subsidiary in Australia, as far as I know, and all over Europe. Michael Zeitler, I want to apologize him. I should apologize him because he is on an urgent trip and couldn't participate. He is the manager of Swidelski UK. So now I have a little bit problem with my. Okay, next one, guys. Okay, let's go into Atos. Atos is originally the name and the company comes from Italy. It was founded anywhere in the 70s and took over by a small Austrian company. And they doing the construction quite well in Austria. Atos has to do everything what means move of construction. So everything what is heavy and to move it, we are doing this job. This small company sold 22. The company, end of 22, the company to, or this part to Swidelski, Austria. And as we see, the market for especially this specialized things is quite limited in Austria. So there's very small market, and we're trying to establish this now in Europe or even worldwide. First of all, I want to show you some things which you already know, or what we are everything what we are doing, and then our newer developments, which happens several projects we already did. This is one is insertion on rails. I guess everybody knows insertions. This is quite famous all over to reduce the interruption of the public railway. We you build the construction beside the railway, beside the dam, and then make the excavation on the dam, stop the traffic for 1 week or 10 days, depending on the size. And then you insert this one. Our investigation here, our new part is we do it on rails. This is developed with the Federal Austrian Railways, has several advantages, of course, also some disadvantages. In any case, it reduces the friction and it's quite fast to do. Some examples. These projects all in Austria. One in Golling, 2017. The load, the concrete was 900 tons and was 15 meters to move. And the speciality here is you have to lift the whole construction 15 centimeter, which is quite a challenge because there's very limited of space. Okay, then the other one is Hiflau, weight 850 tons and the length of 50 meter. Here on the left side, you can see this picture with this special equipment to move the concrete, to move the whole construction. I have prepared movies, so please interrupt me and tell me when there is some buffering or it's not running smooth. We tried it, it works, but nobody knows how stable is the line. Okay, there is no, I switched off the music, there is only music. You see here the moving itself takes around, let's say 20 minutes. 20 minutes, the whole thing was done. And we can make then later on a short stop of the movie. Yeah, here, oops, sorry. This was now mistaken. Okay. I don't want. Okay, once again. Okay, here you see this is the special part. You see the support, how it's supported, and later on you can use the rails. You can see also there is some grease on the top, some special material for sliding. Later on you fill up the embankment, install the rails, and yeah, that's it. But in any case, it takes a few days, maybe 1 week, maybe 10 days, and you interrupt the public transport. Yeah, you see here on the left side, they're already removing the rails. And yeah, so. Okay, it's finished. We're also doing some special solutions. If there is sometimes, for example, we had lowering of a steel bridge. Okay, we're doing also this kind of jobs. We're doing also insertion under federal highway, because this is basically also possible. But this was only done one time. In autumn of this year or maybe next spring, there is also a job, will be a work in Austria for the state highway company. They want also insertion under a highway, so we do it the second time. We're trying to do it the second time. Insertion of a steel pipe on the hydropower station. Here you can see above this man, the red, it's the red jacket. This is the flow, the channel. Yeah, and otherwise you stop the channel and stop the whole project or the whole electricity production. We insert a pipe under this channel. This pipe is for fish, will be later on a fish ladder. Okay. And also when maybe a little bit funny thing was the moving of a single family home. They made a mistake and the family home was 15 centimeter too near to the border. Yeah. Um, as the regulation is very strict here in Austria, they have to remove the house. This was one possibility, and the other possibility was just to move the whole house 15 centimeter to the other, away from the border. So this was possible also to do this. So now this is some general overview. Now we're coming to this checking below tracks, which is a little bit more challenging now. It is what was our target was we try to reduce the interruption of the public railways to a minimum, or let's say to zero. And there we had 41 projects, already the experience of 41 projects. You see here how it goes on, and the train is continuously, of course. We reduce a little bit the speed to 60, 80 kilometer per hour. There is also some examples. This was 1994, made a length of 85 meter, and of course, normally we try to make it rectangular to the track, but in this special case it was not possible, so we have to prolong these temporary small bridges. But was in the end successful. Regarding the temporary bridge, I guess this should be well known to you already. You see here, do you see my cursor? Can you see this? It is here beside, let's say, steel bars. Let's quite easy to and there's the rail in the middle, and left and right is steel bar, which is supporting the track, the rail. And this is supported, and later on, as you can see here, this is already supported by the ceiling, supported by the beams that we have. Okay. How we do it, also the moving one project 2007, we have a quite good picture. This is tank steel rollers, and on these tank steel rollers we are moving the E-beams here and here to this side. Okay, so this will be, you see here, this will be taken in. I'll show you later on a movie as well. This was taken in, and the excavation is continuously during the moving, doing the checking. Okay, this is one project 2008. This was the longest that we did. It was a length of 110 meter. And this is Wörgl, is a quite big railway station in Tyrol, so in the middle of the Alps. And we had 20 tracks. Normally, of course, it should be only the rails, but in this case, we have we have tracks, and we have switches. We have switches to low between this one. Oh, sorry. One example. Okay, so this 110 meter we did not make in one steps. We make it in 3 parts. Yeah, and this goes like caterpillar. Yeah, moving, pushing, moving, pushing, moving, pushing. Yeah, all together at the same time. Okay. Okay. Sorry, what I want to explain before already. This is below the switches. Below the switches is some extraordinary challenge because it's not that easy. But we also investigate and we get a patent for the switches. And the switches, how to move this one, there is a patent, and there was a master work done for all the static analysis, which have to be done. Okay, this is part of the patent. Yeah. Okay, then from our last 2021, this is Berndorf. So to explain you a little bit, this is the connection between the north of the Alps to the south. So from Vienna, as you can understand, to Italy, more or less. Yeah. So this is also quite frequent used track, and this you should not interrupt. Therefore, we have a movie also. You can see we construct this one. You see here this edge. Yeah, this is in front. There is steel, and this one will go through the embankment. Okay, this is the preparation of everything. You see from time to time also hashing by a train. So this takes totally 3 days. Yeah, yes, you saw the trains. This takes around. This is two lines and takes around 3 days, day and night shift. Okay, finishing work. Then this side walls and project is finished. Okay, sometimes you can't do it very close under the tracks because the embankment is too big. There we have another system which is quite similar to the other one. We already finished 3 projects. This is checking in embankments. As you can see here on the sketch, this is the embankment, and you should go through this embankment. You see here the anchors, the temporary anchors. We strengthen the embankment, because this embankment, this railway was built 1870, something like this, and at this time the quality was not so high, not so good made, but still working. And this is the connection between Vienna and Germany, so let's say from East Europe to West Europe, and this is very frequently used. We already have 4 tracks there, and the day and night under operation. So to stop this one is quite quite impossible to stop this one. Okay, from this one you will see later on movie also. Yeah, this was the project in Germany we did 2016 in Oberfellmar. You see here this is this steel edge. So this is the cutter or steel cutter. This is the part which goes through the tunnel, and then you have the side walls left and right side, which will be later on removed. And we go through this one and continuously with the excavation. You see this much more better in the movie. Here you see on the left side in Oberfellmer, this is this special case. Was the special case? There was already existing underpass, but this was too small, too old, so they had space to make it nearby a new one, and this one was just closed. This was also done in two parts. Also again, moving and pulling the other part was first this one in, and then this one to the left side. Because here, with my cursor around here, was very famous, beautiful, impossible to move it tree. And for these reasons, we have to make it in two parts. Otherwise, it would be no problem to do it in one part, which is, of course, easier, faster, yeah, better quality and everything. But okay, impossible to change this tree, so we have to do it in two parts. Okay, 2022, this was our last embankment, checking in the embankment. This was done, as I said already, on this track between Vienna and Linz, or Salzburg is maybe more well known. This was totally 48 meters long and 3,500 tons. And you can see here, this is the support wall. See here, this is already made. This is the slab, which later on will be removed, of course. And then this slab, this was built the underpass. Yeah, okay. And later on, the underpass was moved inside. We used the excavation material to make a hill here, or let's say a better abutment, because as longer as we are inside in the embankment, as more friction we have, and as more pressure we have, of course, also to the other side. Yeah, so there was later on you will see this one. What you can see here on the left and right side, there is some pipes. And these pipes, we filled the gap between the concrete and the material, the embankment or the soil. Yeah, we fill this one with bentonite. Yeah, and with some special material inside also to have a smooth or less friction for this one, because 48 meters is quite a long distance. The total work takes around only the checking was done something in 2 weeks. And the whole project was half year, approximately half year. Okay, I want to show you now the movie. Okay, why is this not working again? Okay. Okay, you see here we're building the slab, this, let's say, sliding slab here. Then it's already done the underpass itself. Yeah, something like 4.80 meters high and 10 meters, 12 meters in the width. Okay, this is half done. Here you see the temporary support. This is anchors going through the dam, which is supporting the dam. And of course, we have a little bit settlement. Yeah, you can see here during the moving, it's the
the lines is on the full operation. We have a little bit settlements, and we have a quite strict measurement system, which was given by the railways, the Federal Railways of Austria, and with a warning, and then later on we have to work on the ballast a little bit, but this happens only one time because we have a total settlement of something like 8 centimeters, so depending on the whole length. And we did not reach the critical part. You can see the excavation. This is the wall, the side walls, and the inclination of the side walls. This depending on the soil character, according to the soil investigation, or water, because even in water we did. Yeah, this is the mucking. And here we feel this hill as a support for the apartment wall. Yeah, okay, you see moving, and then we insert this steel bars, and after the half, we okay, this is already done. Sorry, this was very short. After the half, we removed this one and prolong it, because this was too long, and the unforeseen loads, we could not control this anymore. So it was in the plan and done also to make a concrete slab again, which was done over a weekend, then destroying of these concrete slabs, and fill here again the embankment, left and right side, and here this the cutting shield or cutting edge. This was also later on destroyed, and then okay, and the project was finished. Yeah, more or less this was my presentation. I hope I'm on time, 30 minutes, and if there is any question, please let me know. I try to answer.
Thank you, Wolfgang. You've had a lot of people online. There's 130 plus people all listening to your presentations, and I can see some questions are starting to appear. We do have plenty of time for questions and answers, and hopefully we can get a good discussion going, because it's just as important as the presentation. But now, Wolfgang, you have a more challenging job, because you have some engineers on here who would like to ask
okay.
you some questions. So in the chat, I'm quite happy to allow people to open up their microphones if they want to ask the question. I'll call your name, and then if you want to ask your question direct to Wolfgang, that's fine. See how this goes. If you prefer not to, then I'll let it go quiet for a minute, and then I'll just ask the question on your behalf. But I will start with a chat. I will try a couple on the chat. If you want to raise your hand and ask a question directly because you've made a note of it, that's also fine, but I'll start with the chat and see how we go from there. So the first question I have is from Dominic Greenup. Would you like to ask a question, Dominic?
Thanks, Josh. No, my comment wasn't really a question. It was just stating, you know, in my experience, I've got a little bit of experience of where we've done bridge reconstructions in the UK here, and we've used, I'm not sure if it's actually called a crawler crane, but it's what I've always called them, where we have a sort of crane or pad on wheels that sort of lifts up the deck of the bridge, moves it out of the way, fetches the fresh deck, and then drops it down onto the abutments. I'm just saying it's interesting comparing what I know of that process with what's being presented today. That's all.
Thank you.
That's all I was saying. Yeah.
Yeah. Thank you,
Okay.
Dominic. I don't know
Thank
if you want to add anything to the Wolfgang, or just move on to another question. No, let's. Okay, so next one. I need to get the pronunciation right, and I apologize straight away. Sorry, Dominic, if you can just knock your screen off, if you don't mind, or your camera off at the moment. Tell me from Prakavisa. Please, could you ask a question, or I'll ask it on your behalf. Okay, no problem. So the question here, Wolfgang, is when jacking a box structure under live railway, is there any requirement to pause the jacking until the train clears the area, or is the jacking continuing non-stop with the passage of trains?
Non-stop. This is non-stop, and this is what let's say what was the target, to continuous with the traffic. Continuous with the traffic should go on, but of course you should, and this is depending on railway and a lot of conditions, you should reduce the speed. As you saw this one in Oberfellmar, we said, please reduce to the German railway, please reduce the speed to 80 km per hour. But they said, no need, we go with 120. This is okay, we have no problem. As soon as there are no settlements, and the settlement is, of course, these have to be measured continuously. So because it could always happen that there is something, and you have a settlement, and depending on the line and depending on the speed and all these things, this was given. This is always given by the investor, by the railway. And telling us, okay, up to this limit, there's a warning, and then we have to stop the traffic for 1 hour. And using, now I missed the English word, sorry, for the lifting the tracks with the ballast, doing the tamping. Yeah, thank you. Yeah. Thank you. Tamping. Yeah, it is almost the same word like in German. Yeah. Okay. Sorry.
No
I'm not a railway engineer. This is my problem. Sorry. Okay.
Okay. Thank you. Can I just chip in with a question as a railway engineer? I always like to challenge people. What are the key project risks? What are the things that most concern you and your team as an engineer before you start to make a hole in the railway, or just before the project starts? What are your big project risks? What do you worry about?
Yeah, one thing which should be done quite carefully, but you have to do it in any case, is the soil investigation. Especially with old dams, you should know what is inside, and as much as we know, as more precise we know, as more we can go on with the speed, or do it faster, or make the adopt the inclination of the shield. Yeah. And also recalculate or pre-calculate the expected settlements. This is one thing. Then, of course, water. If there is water coming, okay, we can handle water. We did already project where we have water, but when the water is in the middle of the dam, we will not touch it, honestly. Of course.
I think engineers on this call, especially the UK engineers, would agree. Understanding what is in the dam, or maybe we also call it the embankment, or whatever the substructure is made of. The records, the record keeping, the historic record keeping can be a challenge. Okay, I'm going to open up another question. Andy Batters, would you like to appear and ask your question?
Hi, Wolfgang.
Hi.
So yeah, I just want to understand, how do you calculate the anchor from which you push the jacks?
Yeah.
Or you know, I guess what I'm really asking is, how do you determine how much force is required to push the structure under?
Honestly, I can't tell you quite precisely this number, because it depending on the friction mainly, yeah, depending on the length and depending on the soil conditions, yeah. That's why we use in the last project what we saw, we using this bentonite on the left and right side and fill it. Do you know, have you heard from tunneling the shield method with the pea gravel, which in America is quite often used, pea gravel method in this gap between the shield machine and the soil? You know, there's a small gap in between. There's a small gap between this, between the shield, like in tunneling, yeah, the shield and the other one. And this one this part we filled with bentonite. Yeah, this gives us it supports in one part. It supports the soil. Yeah, that the soil is not breaking down. Which support of the soil means, in fact, less settlements. Yeah, and the other part is, of course, it's more frictionless. You have less friction, and it's easier.
What is bentonite?
Oh, bentonite. I guess it is the English name for this. Bentonite. It's cement and water mixture, and as long as you move it,
like a grout.
Like grout, yes, grout. But grout is grout you pump in, yeah, and then it will be hardened. Bentonite is the different. As long as you move it, yeah, as long as it's moving. If you make a wall, you know, these slide walls, the big walls in the ground, you also use the same material. As long as you move it, it's liquid, and when you stop it, it gets hard. Yeah. That's why interruption of the work for a few days, this should not be considered. This is not a good idea, because then it will be hard, and to start to press again, this makes a lot of settlements and friction, and yeah.
Okay.
That's why we fasten up. Yeah. Okay.
Right, thank you. Only rushing because we've got 15 minutes, and I can see an answer to the question that I'll come on to in a minute. So, Ricardo, would you like to ask your question that's in the chat? If not, that's fine. So Ricardo asks, any particular constraints to consider when working under electrified lines? So electric traction supply.
No. Because as you can see here, all of them is electric lines, and this doesn't matter. It's not.
That's easy. Let's move on. Steve Denton, do you want to ask your question?
Hi, Wolfgang.
Hi.
You sort of part answered my question about jacking under ballasted track, but I was really, when I typed it, I was sort of specifically thinking about where the track sits on the roof of the underpass that you're pushing through.
Yeah.
How do you sort of monitor the track alignment, and how do you stop the track from slewing over and the vertical alignment sort of being messed up as you jack underneath?
Yeah, we have a permanent measurement program. It is a little bit maybe difficult to explain. We have some points on the rails, yeah, and permanent measurement, automatic permanent measurement, and we have this even online. Everybody can see this on this mobile phone or on the computer, wherever you want, and you see immediately, okay, if it's continuous here and getting too much or getting to the critical settlement, then we stopped for this takes maybe half hour. Stop the line for half hour and fill the ballast or lift the track again. But at in the last project we had, the funny thing is the drivers, the locomotive drivers, they did not say anything. So normally they feel this, when it starts to jump, when they go with high speed there, but nothing. That's while we were already on the critical path, nearly to 8 centimeter, 9 centimeter settlement, and the chief of the line, he says, continue, doesn't matter, no problem at all. So
thank you, Steve. Thank you for that. And Tony Bulgani, I think, has just made a comment here to say a separate presentation on design, planning, and installation of the support frame would be due. Maybe we can consider that one for next year. Dave Thompson, you have a question there, but Dave, I think you're also, good to see you, Dave, also think you can clarify the English translation
of bentonite. Yes, it's a kind of clay, basically. I think it's a tropic clay. So once you agitate it, it goes into a liquid, which is why it's so useful for slide purposes. And of course, as soon as you stop, it sets. So it's a similar sort of thing to non-drip paint. It's the same base substance to that. I think someone else put a link in as well to the use of bentonite in construction. It's fairly common for those sorts of excavations that it's used. That was one thing. Now, my question was to do with steering the units. When you've got a long unit, there's a tendency for the units to dive or rise, and you reported a little bit of that. How do you go about steering those units when you're jacking?
Yes, you have the possibility of steering, of course, because with the jacks you can move a little bit and going up and down. This is quite, let's say, quite easy. This one I should show you on a picture, because the excavator in front, what he's doing, he's excavating a little bit more, on the bottom, so then it goes down. And when he said, okay, it's too much down, he's putting some material there on the bottom, on the floor slab, and then because the floor slab itself it's not straight, it's also edge, You understand? It's like you see my hand. It's like this, like this, okay, like this, It's like so. And so he putting material here, and then it goes up.
Oh, I see. So
and then he take away the material and it goes down.
I get it.
This is and left, right. It's quite simple. And left, right. It's doing with the jacks.
With the jacks.
So normally we have something like 2 centimeter. And in the last project it was this 48 meters. We had 2 centimeter. We were not precise.
Very good. Yeah, very good.
Yeah. And this is, I think, normally acceptable.
It's absolutely.
Yeah.
Thank you very much for that.
Thank you, David.
Thank you. Thank you for the explanation of bentonite.
And Steve Williams has put a little link to some more information about how that can be used. Ralph, you have a question about patents. Do you want to ask that?
Yes, so that's very interesting. Thank you for the presentation. Refer to a patent turning when you.
So Ralph, you're a little bit quieter. Can you move to the mic or just turn the volume up to now?
Yes. You referred to a patent involved with jacking under the switches. I wonder whether are there other patents involved with all the other things that you've described to us?
So I did not understand very correct, because it is always stopped. Can you please repeat?
I think I got that, Ralph. You talked about a patent.
Okay. This for the switches. For the switches.
I think Ralph's question is: are there any others? Are there any others involved in your processes?
No. This is the only one. This is the only patent we have. All these other things is based on the experience.
Okay.
It is.
Okay.
It's
Thank you.
on.
Sorry, one more question then. So one more question from Stuart Corrie, and then we'll start to wind it up unless somebody wants to throw one in quickly. So Stuart, do you have your question?
Yeah. Have you ever attempted to do this on an embankment that's subject to seasonal shrink swell due to soil moisture deficit problems?
Yeah, honestly not, because if you have an embankment with swellings and shrinking, you have already a lot of problems with the track itself, no? With the alignment, with the track.
Yeah.
Did I understand the question correct?
Yeah.
Yeah, because then you have already the problem in
Yeah.
the embankment, and in the embankment itself, when you have the problem, or you should remove the embankment and make the embankment new, because this will not solve your problem in the end. Yeah, especially when you with water, no? When you have some material which is going bigger with water, no?
Okay.
Thank you.
Do you mean was this your question? Sorry.
Yeah. No, it's
yeah.
I was seeing if you had any see if there was any experience involved in that, because we've got quite a few clay core embankments built in this country that aren't particularly well constructed,
Okay.
for want of a better description.
Okay. I mean, it helps itself because in this area, yeah, where you make the underpass, there is no material anymore, so this cannot shrink and cannot swallow. It helps, but we had in Austria also in tunneling a lot of problems with this material, especially in tunneling, and in the end they have to renew the tunnel. Yeah. So this there was no other possibility in the end.
Okay, I'm going to finish the Q&A there.
You.
Thank you very much for everyone who's engaged in that Q&A. That was a good session. Now, before we say goodbye to Wolfgang, and before we thank Wolfgang for his presentation and those that aren't raised the questions, just a quick reminder that the next presentation, next Lunch and Learn, PWI Lunch and Learn, will be in 2 weeks' time. The chair is a good friend of mine, Darren Sharp, who most of you know, and we'll be hearing about Excalibur screw bolts and how they revolutionised the construction fixings industry, and their story about their Queen's Award, and there will be plenty of technical discussion about how and when to use them. But in 2 weeks' time, that would be to dial into. Of course, the links will be sent through. Finally, can we turn off our microphones and just give Wolfgang a large PWI round of applause, and thank you very much for the presentation.
Thank you very much. It was great.
Thank you very much.
Thank you.
One